Welcome to The Explainer. Today, we're going to break down one of the most powerful and, honestly, most efficient architectures in modern AI, the mixture of experts. This is the secret sauce behind some incredible models like Mixtral, and believe me, it is completely changing the game. So, the big challenge in AI right now is this classic trade-off. We all know that bigger models tend to be smarter models. But the cost, oh my, the computational cost, the sheer amount of energy and money it takes to train and run them is just becoming insane. It's pushing us to ask a really important question. How do we keep making AI smarter without completely breaking the bank? And that, right there, is what we call the AI scaling problem. For years, the playbook was simple. If you want better performance, just build a bigger neural network. But we're really starting to hit a wall where that strategy just isn't sustainable anymore. You see, for years, AI research was totally driven by this one core principle. What it's basically saying is that size really, really matters. If you've got a set amount of money and time, you're way better off building a gigantic model and training it for a shorter period than training a smaller model for a longer time. This single idea is why we've seen this incredible race to build bigger and bigger and bigger models. Okay, so if we can't just keep building these massive, dense models where literally every part of the AI is fired up and working all the time, what's the alternative? Well, this is where a really clever solution comes into play, the mixture of experts, or just MO for short. It's a way to get all the brain power of a huge model, but without that crushing computational weight. At its core, the idea is actually beautiful in its simplicity. Instead of having one giant monolithic brain where every single neuron has to work on every single problem, an MoE model is more like a team of specialists. You've got lots of smaller expert networks and a smart router that looks at a problem and says, you know what, you're the right expert for this job. Let's use an analogy to make this super clear. Think of a traditional AI model as a company where every single employee has to go to every meeting and work on every single project. I mean, sure, it might get the job done, but it's incredibly slow and inefficient. Now, an MoE model is like a well-run company. You've got a manager, that's the router, who looks at a new task and sends it only to the specialized team that's built to handle it. It's way faster, way more efficient, and just scales so much better. All right, let's get into the nitty-gritty. There are two key parts here. First, you've got the sparse MoE layers. This is basically where your team of experts lives, and each one of these experts is its own little neural network. Then you have the second component, which is really the brains of the whole operation, the gate network, or router. Just think of it like a traffic cop. Its entire job is to look at the data coming in and intelligently decide which one or two experts are perfect for that task. And the secret sauce, the real magic behind all of this, is a concept called conditional computation. All it means is that for any single task, only a tiny fraction of the whole model actually lights up and does any work. The rest of the experts? They just stay dormant, saving a massive amount of compute power and time. That is the key to its efficiency. Okay, that sounds awesome in theory, right? But how in the world does the router actually know where to send the data? Let's take a look at how these experts get picked. The process is actually pretty straightforward. So picture this. A tiny piece of data, we call it a token, shows up at the MoE layer. The router network immediately analyzes it. Then, based on what it sees, it makes a smart call and picks the best one or two experts for that specific token. And finally, only those chosen experts wake up and get to work, while everybody else just waits for a job they're better at. Simple as that. But wait a second. This brings up a pretty obvious problem, right? What stops the router from just playing favorites? If it decides one expert is a superstar and sends every single task its way, well, that would totally defeat the purpose and just create a new bottleneck. The solution is actually a really clever trick they use during the training phase. They add a special rule called an auxiliary loss function. Think of it like a penalty system. The model gets penalized if it overloads one expert and leaves the others with nothing to do. This forces the router to learn how to spread the work out evenly, making sure the whole system stays balanced and super efficient. And what's crazy is that this idea, it's not new at all. The basic concept has been around since 1991, but for decades, it was just an idea on paper. Then, computing power finally caught up. In 2017, we saw researchers scale it up to a massive model. By 2021, Google built a mind-blowing 1.6 trillion parameter version. And then, in 2023, Mistral's Mixtral came along and brought this incredible architecture into the mainstream, changing everything for pretty much everyone. So let's take Mixtral as the perfect example. On paper, This model has a staggering 47 billion parameters. That is a truly massive number. But, and this is the absolute kicker, this is the magic of Mo, it actually runs with the speed and the cost of a model that's only 12 billion parameters. Now, you can think of parameters as like the neurons in the AI's brain. So how does it do this? Well, it all comes back to that conditional computation we talked about. It has this giant brain, but at any given moment, it's only using a small, specialized part of it. This gives you the raw power of a giant with the speed and agility of something much, much smaller.
All right, but let's be real. Like any tech, this isn't some magic wand. Mo models come with their own unique set of pros and cons. So let's take a look at the trade-offs. And this table lays it out perfectly. On the plus side, the pros are huge. Pre-training is way faster. Inference, which is just a fancy word for actually using the model, is also a lot quicker. But there are downsides. They can be really tricky to fine-tune for new tasks, and sometimes they overfit, which means they just memorize new data instead of actually learning from it. And the biggest demand is memory. Even though you only use a few experts at a time, you have to load all of them into your GPU's memory, or VRAM, and that requires some serious hardware. So let's dig into this fine-tuning puzzle a bit more, because it's a real challenge. Part of the problem is that since only a few experts get activated for any piece of data, it can be tough for the model to learn general lessons from a small set of new examples. They also just behave differently, and you often need to tweak things like the learning rate to get them to work right. But the really exciting news is that researchers are already finding solutions, and a technique called instruction tuning is showing incredible promise for unlocking their full power. So, what does this all mean for the future? Well, in one word, sparsity. The future of powerful, efficient AI is looking a lot less dense and a lot more specialized. And man, things are moving fast. Researchers are working on all kinds of cool stuff. There's distillation, where they're trying to compress all the knowledge of a giant MoE into a smaller, easier-to-use model. They're also exploring quantization to shrink that massive memory footprint. I mean, there are techniques in development right now that could take a model needing over 3 terabytes of memory and squash it down to just 160 gigs. And of course, the work never stops on making the router itself even smarter. So if you take one thing away from all this, let it be this. The mixture of experts architecture is a total game changer. It breaks that old rule that bigger has to mean slower and more expensive. It lets us scale AI to new heights, but in a way that's actually sustainable and way more efficient. And that leaves us with a really fascinating question to chew on. For years, the goal was always to build one giant do-everything AI. But as this expert-based approach gets better and better, you have to wonder, is the future of intelligence not one single giant mind, but a perfectly coordinated team of specialists? Could the whole idea of one model to rule them all actually become a thing of the past?